so this is kind of tentative first draft at the groups, right? So there's some drops, some ends. I know there are a few people in here that are auditing or kind of debating whether or not they want to stay in the course. So definitely keep me in the loop as things are changing, right? If you have any concerns about any of these groups, then definitely let me know. The groups are a little bit bigger than what I was expecting in some cases. So if you find, especially when we get to working with the hardware, if it makes sense to kind of have subgroups within your group, then that's something that we're welcome to explore as well. There are a few people who, like I said, are auditing the course. So I kind of have you listed as maybe you want to potentially consult with a group. I know that you're probably not going to be doing the lab reports and stuff. So if you want to reach out to those teams and kind of say, hey, I'm open to collaborating with you. Yep. So one of our auditors who has some ROS experience, so, definitely a good resource. So just as long as those teams are aware that those students are auditing, so they're not going to be contributing to the report, but they might be a good resource for debugging purposes, as having that extra person to collaborate with. But as I said last class, if at any point you find that things aren't quite working in your team, maybe you want to do a little bit of shuffling. Maybe there's this subgroup within the team that's working really well together and you want to kind of branch out a little bit. Just keep me in the loop with that so I can keep track with my records, because I really do want this to be a good experience for everyone. And I know, as you may have experienced in the past, I for one, that teams can be a little bit difficult to work with sometimes. So hopefully we'll be able to address that. I know there's a lot of people that are really interested in this topic. So hopefully it's a good overall collaborative experience. All right, so kind of the schedule for today, what I want to do is hopefully try and get the VM, so the virtual machine software, get that started downloaded. One of the things is that the company VMware that I used last year, they got bought out by Broadcom. So it changed a little bit on what the steps are for actually getting that software set up. So we're going to try and get that debugged here, get you started downloading the virtual machine image itself. So we'll do that at the beginning of this class, get your account set up, get things started downloaded. And kind of while those are downloading in the background, what I want to do is go over some of the Linux system basics. Based on what I saw, there's definitely a lot of people who don't have any Linux experience, so don't get too put off by that. Definitely, I was learning Linux as I was teaching the course last semester, and it's one of those where you'll find that some things it's like, man, I wish I could just do this as easily in Windows. Other things you're going to say, man, why is this so much harder than it is in Windows, right? Just whatever you get used to, you'll find that it might seem a little bit intimidating at first. Once you get a handle on it, it's actually not that bad, especially with the version of Linux that we're using. It is meant to be more user-friendly. You'll notice a lot of the interfaces are pretty similar to what you might see in Windows. So it's a good kind of introduction to Linux systems. And then if we have time, go over a little bit of high level of what ROS is. And then whatever time we have left in class will be just to continue working on Lab 1. So if you haven't had a chance to look at the labs, right, so this is kind of the way that they're structured. So this virtual machine setup, that's what we're going to be kind of starting with today. So if you can open that up from Piazza, that'll also be helpful because some of the links are in there. So the first thing is there's a system image from Yaboom. So Yaboom is the company that makes the robot that we'll be using later in the course. And so this image that you're downloading, what it means is that when you go to work on the robot, the system is going to look the same to you, right? So it kind of helps you get a feel for what that's going to look like when you're interfacing with that robot. One thing to note, this is a .rar file. So if you don't have 7-zip, you only have the built-in Windows unzipper, you might need to install this as well. because this will allow you to extract files out of that compressed file. Right? If you don't know what that means, definitely ask, and I can help you out with that. Right, so digging a little bit into maybe kind of CS stuff. So I know we have some Mechis in here. Don't get too put off by it. I'll help you through it. The virtual machine software that I'm proposing to use is VMware. I had seen it suggested that VirtualBox might have some quirks with this particular virtual machine. If you do already have VirtualBox and you're comfortable with it, you're welcome to go ahead and use that. Just kind of note that it might be a little bit different compared to what other students have, so you might have slightly different quirks when you're working through the different labs. So previously, there was a free version called VMware Player, and now it looks like Broadcom has made VMware Workstation Pro free. So we're going to follow through these instructions from the Broadcom website. So you will have to set up an account with Broadcom. From what I've found, they don't send you emails or anything like that. So that hopefully shouldn't be a problem. Just use your RPI email to set that up. And once you create your account, then you should be able to log back in. And you can see that there's some instructions on how to get to where you can download the Workstation Pro. If you want to try and get the latest version of that, this will work with Windows or Linux. If you're somebody who has a Mac operating system, then we'll have to kind of work together to figure out some alternative, try and get ROS installed on your machine itself, just because unfortunately Macs don't play nice with a lot of the virtual machine software. And then once you kind of get that downloaded, get everything started downloading, then we'll switch over to talking about Linux systems in general, right? So kind of make the most effective use of our time. And then after that, kind of you can start off after we go through lecture material with making sure that everything is set up with your machine so that you can access the internet. And what we'll see later is that you can also connect GitHub to it and all those other sorts of things, right? So I said what we're going to start with. One thing is because this is all on a Google Drive folder, so I'm not sure if all of us trying to download it at once might freak out Google Drive a little bit. So some might have to download that a little bit later. Broadcom is big enough that hopefully that shouldn't give us any problems. All right, so we'll start with that, and I'm available to help you out if you have any issues following through these instructions. Try and help you through that. Okay. And I'll just kind of poll periodically to see how everybody's progressing on getting those two started downloading. Okay. So Yahoo, they have a lot of these great resources for working with their different robots. So this one is for the ROS Master X3, which is what we'll be using. I think they have a image here, maybe. All right, so yes, that's components list. All right, so you can kind of get a feel for what the robot is like. LiDAR sensor, RGBD camera, that sort of thing. One unfortunate thing with this website is that it doesn't have kind of the link up here to a specific page. So anytime that I tell you this page, I'll try and tell you which section you actually need to look at. A little bit unfortunate, but so if you go to, you only want to look at the ROS 2 stuff. Used to be a ROS 1 robot, so they had that here as well. So ROS 2, Linux operating system, there's the virtual machine installation. So some of this is a little bit older of a version, but a lot of it should translate pretty well. Just to set up, actually connect your virtual machine to VMware, right? So it's going to look a little bit different. If you look at the new version. Right, so what you're going to do is you're going to actually open a virtual machine, and you're going to find inside where you extracted that .rar file, there's going to be a virtual image in there. And so what happens when you open that for the first time, it might take a little bit of time to actually boot up. A couple of cases, maybe much as like 2 minutes. So just gotta keep that in mind. Just take a little bit, because essentially what it's trying to do is allocate space for that virtual machine to work. And on some systems that might take a little bit of time for it to do that, especially if you're using up a lot of your hard disk drive already. It can make that a little bit more difficult. But then what you can do is you can actually click on the image. Oh, actually, second one. All right, so as you can see, one thing that happens sometimes is the display gets a little bit wonky. So if that happens, so kind of introduction to Linux system, what's nice about this version that we're using, which is Ubuntu, is that it is pretty similar in some ways to like a Windows machine. So this is where you access all of the applications. And so if you do a search, if you go into settings, so sometimes you'll notice that it gets really small, right? So you can see here, it messed up my resolution. So this is in the display. It's going to be down here, and 20 by 1080 is usually what works well. You can apply that, right? So now you can see things are scaled a little bit more appropriately. So that's kind of the first weird thing that you might encounter once you actually get into using the virtual machine. So if everyone is okay with me continuing, I'll actually go through a little bit of what Linux is, some of the benefits, some of the things that might be a little bit unusual to get used to at first. Right, so Linux system, why it is as popular as it is, it's free, it's open source, and it actually has a lot less vulnerabilities. It has a really strong community, and since it's open source, there's a lot of kind of like Red Hat, break it and figure out how to fix it. So it tends to be a lot less vulnerable and more stable than, say, a Windows system, right? So there's that whole thing not too long ago that crashed a whole bunch of Windows systems. Linux usually doesn't run into anything like that. Some of the cons, there might be some software that is not available for Linux systems that you can find easily for Windows, just because Windows is the more popular one. But a lot of it, there is some kind of variation that you can also use in a Linux system. And there's actually multiple distributions of Linux. So a little bit different. You could maybe kind of think of it like how you have, Windows 95, Windows 10, Windows 11. Kind of what's going on under the hood is more or less similar, but there's these different versions of it. Linux, you have all these different distributions that main difference kind of between the different distributions is how customizable it is. So you can get some Linux distributions where there is zero graphical interface, right? So everything is done completely in the terminal, right? You can't actually visualize anything, but you'll see that maybe on server systems, all the way to something like Ubuntu, which is probably the closest equivalent you'll get to Windows in terms of the interface that you have. Looks pretty similar. You can do a lot of kind of the file navigation and stuff the same way you would in a Windows system. And so it tends to be a little bit more user-friendly for those first-time users that are getting into using Linux systems. But generally what we're going to be doing a lot is using the terminal. So the terminal, if you've ever used a command prompt in Windows, same kind of idea. It just turns out that with Linux, And instead of using your mouse and for everything, pure for navigation, getting through everything on your system, you tend to do everything in the terminal for a Linux system. Okay? And so we'll see the same thing with ROS, is that we're going to be utilizing the terminal a lot. A little bit maybe daunting at first. Once you get comfortable with it, it's not too bad. So people who are really good with Linux systems, you'll actually see that they pretty much never touch their mouse. You can do everything right from the terminal if you know what you're doing. Right? If you're not as confident, Ubuntu makes it a little bit easier to kind of merge the two, increase your comfort level with using some of this. Right, so we'll see there's a lot of interesting things that come up. So there's this idea of typing. We'll see that a little bit later, but it actually allows you to combine a bunch of commands together. And so what we'll see this is useful for is for something like, right, so if I open a terminal here, probably gonna take a minute. Want to go. A second here, let me. So another useful thing that I'll mention a little bit later, Control-Shift+ allows you to zoom in on your terminal, right? So it helps sometimes, depending on the resolution that you're looking at, might be a little bit hard to see what's going on in your command window. So that makes it a little bit easier to do. Okay. So what we'll see where piping comes in very useful is, so I just ran this command. What this is doing is it's listing every ROS2 package. So packages are kind of groups of code that do something similar, right? So we'll talk about what that is a little bit later, but kind of this idea that I have all of this stuff here that got outputted by that one command, right? Not super useful for me to dig through there, but what I can do is I can actually filter and have it only output things that contain, in this case, RQT, right? So really powerful things that you can learn inside the terminal. And you'll see on Piazza, there is a kind of quick reference for Linux as well. I encourage you to take a look at that. As you go through Lab 1, it'll go through a lot of different commands there as well. Right, so I like to bring up, you'll see this a lot, especially when you just kind of Google stuff, that there is this sudo that they sometimes put before commands. So sudo is almost kind of like that administrator override. So basically you're telling it, I definitely, for a new Linux user, use this cautiously, right? So if you're putting commands and it's telling you, are you sure you want to do that? Maybe that's something that you should verify. Are you sure that you want to do that, right? Sudo is a way to kind of override some of the restrictions that are in place. So if you do come across that, there are some cases where a command won't run unless you do use sudo. So make sure that it's the right command that you're actually running. Right, so in the terminal itself, probably one of the key things that's going to save you a lot of time is tab complete. Right, so if I am trying to navigate within my terminal here, right, so I want to move to the desktop, I hit tab, it auto completes it. Now I can see on the desktop there's that S25. I start to type it, tab, it auto completes. Right, so very useful time saver. Where you'll find it also helps a lot is if you misspell things, as we actually had that in the lab that I was working with. somebody really misspelled the name of a file, every time I tried to type it, and then I found out, oh, you can do tab complete and it'll handle that for you. All right, so as long as you have enough, like if I had 3 or 4 folders which started with S25, then I would have to include a little bit more information to get it to tab complete. But it can only be helpful to navigate and fill in those commands when you're working with them. Right, you can also open up new terminals. Right, so one thing that is a little bit different. So notice when I did this CD, right, change. So when these commands, you're actually putting them in a specific place in the file structure, right? So when I did this CD, now it's telling me that where working is in this little tilde is your home folder. And then we went to the desktop, then we went to S25 ROS course. And this is where I am operating at. And so if I do a Control Alt T, right, so Control Alt T, right, so you can see it opened a new window, but notice the location that I have here. Right, so when I open a new window, it actually goes back to the home folder. Right, so this is something to keep track of if you're trying to do multiple things in the same location. That means if I wanted this to be occurring in that same location, I would have to use the CD here to get to that same location. Okay. If instead you do something like a Control Shift T, you can see that this tab opens up in the same location that you were previously in. Right, so different little shortcuts that you can use if you're saying, well, this just sounds awful. What's nice about this interface that I'm using, which is Terminator, is you can right click, I can split horizontally, I can split vertically, I can tile a whole bunch of terminals together. So what we're going to see when we start working with ROS is that there'll often be times where you have one thing running in one terminal, something else running in another terminal, maybe you're running a third thing in a third terminal. So using this Terminator instead of the base terminal can make that a lot easier for you because you can do this tiling. Right, so I will note that on here. So when you first start up your machine, you notice that I have these shortcuts, right? You might not have those initially. So if you type into the search your terminal, so Terminator is kind of an add-on. You can add it to your favorites. Right now it's already on the favorites, so my option is to remove, but it'll actually add this shortcut here so you don't have to keep trying to find that terminal. I also have listed on the PowerPoint a bunch of additional commands, right? So if you are someone who wants to get a feel for what it's like to basically not have to use the mouse, you can also open and close terminals. You can minimize windows, get back to the desktop. So that can be useful if you have a whole bunch scattered all around that you want to get back to. With terminal itself, right? So note that I'm saying terminal in this page. So as I said, you can see that I have 2 separate ones here, right? So there's terminal. So this is kind of the default that is built in with Ubuntu. This Terminator is one that was installed later, but as we can see, it has a little bit more powerful functionality and that you can actually divide up your terminal into different panels and kind of move them around together. So both of these will do the same thing. Some of the commands are slightly different. So once you get used to using one, I would recommend just sticking with that one. Terminator might be the easier one to start with. They'll make it a little bit nicer later when we're actually working with ROS. Right, so some of these already kind of talked about with Terminator. Turns out that there's also keyboard shortcuts. So depending on what your comfort level is, like I said, you can always use the mouse, do right clicks, right? If that's what you're more comfortable with coming from a Windows system, you're definitely welcome to do that. If you feel like I want to, see what the quote unquote real Linux experience is like, you can try and get a feel for using all of these keyboard shortcuts. Right. So in general, some of the commands that you're going to be seeing a lot of, apt-get is a way to install software. If you go to like the super newest versions of Ubuntu, I guess that has changed since they got a new company managing them. But you'll come across this a lot for actually doing your software installations. Right? So a little bit different from a Windows system where you go to a website, you download an installer, and then you run that file. With Linux, you can actually do an apt-get, provide to it what it is that you want to install, and then it handles that installation. They already kind of saw me use this. ls is a way that you can list everything in the directory that you're working in. So this can be very useful when you start having a whole bunch of files in different locations. Maybe you don't exactly remember the name of something. You can use that ls to see everything that exists in that space. CD, you've also seen me use. You'll play around with this a little bit in Lab 1. So with CD, there's a couple of shortcuts which allow you to navigate a little bit more easily, right? So let's take and go here. No, I do not want to shut down. That would suck. All right, so if I do like I did before, navigate to a folder, and now if I wanted to go back to, say, my home directory, I can use a shortcut, CD, the little tilde. So it's that key up above tab, right? The little tilde there that you probably never really used before. It's a shortcut to bring you back. So no matter how deep you are into your file structure, you can get back to that initial home directory. And if you're kind of navigating down through, right? So I can move to my desktop. I'm not quite sure where I want to go to next. Oh, maybe I want to go to Lab 1. Right, so I'm navigating to the next folder down. I can see what's going on in there. If I wanted to move back up the structure, if I tried to say CD desktop, right, because it only knows what is in the directory it's currently in, right? So we can see with the ls that it sees these files. It has no knowledge of where the desktop is. So if you want to go to the desktop, you can either use the full path, right? So I actually CD to that desktop. Or if I know that I'm just moving up one, then you can use the shortcut // move yourself back up the file structure. Right, so a little bit different doing the navigation here than it is in a Windows system. Right, but if this is a little bit intimidating for you at first, what you can do is you can click on the files here, and now you see, ooh, it looks like Windows, it's okay, right? So this can be, pair between the two, kind of get yourself comfortable with using this. If you kind of get to the point where you're getting a little bit frustrated, you can go in here. I see, oh, I'm in my home, want to go to desktop, want to go to Lab 1. And what I can actually do is right click and I can open in a terminal. And now I can see that it opened up a terminal in that specific file location, right? So it gives you some alternatives. If you find trying to do this navigation is a little bit daunting at first, you can start with using this that's a little bit closer to File Explorer to get a feel for how things are structured. And you can always use that as an alternative way to navigate through. I definitely encourage you to try and get used to using the terminal. As you get more experience with it, you'll find that it will actually save you a lot of time. Right? It's surprising how much time it actually takes to move the mouse and click to different things versus just doing these quick navigations in the terminal. Right? But that's the nice thing about Ubuntu. It gives you that flexibility if you want to approach it from different ways. If at any point you're not sure where you are, you can always do PWD, prints out the full directory of where you're located. Where this could happen is if you have a really complicated file structure, right, you might end up going several layers deep. And so what you might find is looking at the terminal where I showed you before in this initial that it tells you where you're located, it might actually start truncating that. So you don't have multiple lines of it just saying where it is that you're located. You can always use a PWD to figure out where you are. It's like in this case, right? So I can see an interesting thing here is that that tilde actually holds multiple things, right? So I called it the home folder, but technically there's a little bit more going on here, right? So we go here, right? So the Yahoo I was referring to is kind of like the user, right? So a little bit different than what you're used to maybe in the Windows system. Back here for now. All right. It's another useful one. You can also make directories, make folders, right? So I said you could do that the way that maybe you're more used to, or you can actually do that in the terminal itself. You can also create empty files. So this is another thing that when you're coming from Windows is a little bit confusing. So I could actually create a file called, say, test.txt, and I can run it in Python. As far as Linux is concerned, the dot whatever is absolutely meaningless. Right? So a little bit kind of a weird idea because we're used to in say like a Windows system, if you click on a Python file, it runs it in Python. Right? It uses that that additional dot whatever to know what it is that is actually running. So if I actually look at here, right? So if I open up a file, so if you've seen Python files before, you've probably noticed that it has this weird line at the beginning, and you might not have known why a lot of files include that. And the reason why it's included is for Linux. So the only way Linux knows how to run a file is with this initial line. So this initial line is explicitly telling it that to run this file, I'm going to use Python to do that. Right? So if you don't include this line, right, and you try to run the file, it's not going to know what to do with it. Right? So a little bit different than what you might be used to. So it turned out if I wanted to, I could rewrite this as looptime.txt or whatever it is I want to call it. Really the .py is just so the user knows what the intended purpose is of that file. So a little odd quirk to be aware of. And this is another thing that you'll explore in the lab, that there's certain ways that you can run files, and there are certain permissions associated with files which will allow you to run them or not run them. Okay? So you play around a little bit with that as well. Some additional things, you probably won't use this as much, but you can copy folders, you can move folders. You can also remove. I would not recommend that if you're new to Linux. Yeah, I'm sure I actually want to completely remove this file. I don't care about it. I would recommend, if you're going to start deleting things, maybe doing that in the files that's more like a file explorer, just until you're comfortable with knowing what your commands are doing. Right? Because unfortunately, there's not just a quick, resurrect this from the recycle bin like there is with Windows. Right? So things to be cautious about. And that's why we're also going to recommend that everyone's going to have a GitHub account. So you'll have a GitHub repository for your team that you can upload your proof of completion. But I'd also recommend that you have your own GitHub as well, and that you can upload your files. Make sure you always have a backup, just in case you accidentally run something that maybe you shouldn't have been running, right? So always good to have that available. Some other interesting things that you can do is, if you don't actually want to open a file, but you want to see what's going on in it, you can actually print out, right? So let's say I go to this file here, and let's say I want to see what's going on in the time. You can actually print out the file right there in the terminal, see what's going on. If, say, it was a really large file, or you wanted to do a quick check of something, you can print specific lines, right? So in this case, maybe I was interested in everywhere that I use this variable current, and I can see all of those specific lines, right? So maybe I was running this file and I was finding that it seemed like the output isn't correct. I can check all of the lines where I actually use it, make sure that I'm assigning the value like I wanted to. So lots of things that, when you get used to using them, could potentially be helpful for you for debugging purposes. What else we have here? Okay, so another one that I've used a couple times, my apologies for not mentioning what I was doing. If you use clear, that's going to clear everything out in the terminal. If you don't actually want to clear it, but you just want to kind of start your line at the beginning, turns out you can use Control L. So you still have all of your commands that you can scroll back and see, but they're not all cluttering up your current view. A couple other things we'll look at. Processes, things like that. You'll play around with that in Lab 1 as well. So it turns out that you can have things running in the terminal, you can cancel it there, or you can have things running in the background. And so when you want to stop things running in the background, it gets a little bit more interesting on how to do that. Okay. And the one that is probably going to irritate you more than anything else, copy paste. You have to use Control Shift to do copy paste. Okay. It's going to take a while, and especially when you're switching back and forth between Linux and Windows, it's going to be a little bit annoying. Hopefully, once you've used it a few times, you'll kind of get in the mindset. This is the Linux system, Control Shift C, Control Shift V. This is the Windows system, Control C, Control V. Right? So definitely one of those. Take a little bit of getting used to. It's a little bit annoying. So sometimes it's like I expect something to paste here. Why isn't it pasting? That's probably why. Doing in and out of terminal, we already looked at that one. There's a few other commands as well. If you're trying to figure out what a command does, or you're trying to figure out where a certain file is located, there are shortcuts for that as well. That can give you a little bit more information. You can also find things. What might be really helpful for you as you're starting out using a Linux system is that you can use this help. Right? So, for example, right, so you saw me use ls a lot. So if I do ls help, so it's going to give me all of this information about the help function. Right? So here's all the things that I can use with it, and here's what those options do. Right? So very useful as you're first interacting with these different commands. Like, what can I actually do with it? What is it trying to do? Right? So you can see there's a few here. So this is an interesting one that we'll take a look at in a second. But lots of different options. Some of these are going to be a little bit bigger than others, but it's a good first kind of check to see what the function does, give you a little bit of insight as to what it might actually be useful for. This one again, I've used a little bit. So definitely if at any point I start typing or doing things that I haven't mentioned and it's not sure why I'm doing it, definitely interrupt me and ask. That's one example of where I was doing that. Now that my mind is back a little bit more in the Linux mindset, I'm actually starting to remember again some of these. But as you saw with something like grep, that this is essentially a string filter. So it's actually going to look for whatever that string is, can be helpful to kind of filter out output from a command. Probably not something you'll run into, but it turns out if you have very specific command pairs that you run a lot, that you can actually assign it a different name. So if, say, really you run like this ls grep a lot, you can kind of group it together as one alias name and basically have a shortcut for running those commands. So obviously if that's something you're interested in, you can also write outputs to a file. Okay, so maybe if you want to run a certain file, or you want to run ls and you want to keep track of everything on the outputs, you can actually write that to a file if you want to. Okay. So all of that is things you can do in the terminal. Like I said, in lab 1, it'll walk you through using a lot of these functions that we touched upon. Hopefully give you a little bit of context as to why we're using some of these, why they might be useful a little bit later. So that's all well and good for navigating, finding things. Now, what if you actually want to edit a file? So this is another one of those where, luckily, because we're doing Ubuntu, you can kind of pick and choose what you're more comfortable with. So if you are a primarily Linux or Windows user, then you might like using gedit better. So essentially it looks like Notepad, right? You can go around clicking it, right? Type things out. It's essentially just like using Notepad, right? So if you're someone who, as you're using the terminals, I really hate using the terminal, this is one way that you can edit your files that might be a little bit more familiar to you. If you're somebody that says, well, I want to try and see what it's like doing everything in the terminal, then there is this VI. So VI, now we're actually editing the file itself in the terminal. The biggest thing that is annoying to get used to is right now it's in command mode. So I can't actually edit anything. But if you hit I, so now you can see in the bottom, it says insert. And so now I can actually edit my file. Right? So I can make those changes to it as long as I'm in insert mode. Then I can use the escape key to get out of there. And then if you actually want to close your file, then colon is the way that you start commands. If you want to save, use a W for write, a Q for quit, and now you're back in the terminal and it has saved and written your file. Right, so two different approaches that you can take. You kind of go back and forth between the two. You know, maybe get a feel for doing things in the terminal if you want. If you find, no, this is just a little bit too much for me, then you can jump back to gedit, right? Completely up to you. You have that flexibility to use whatever method works best for you. There are a couple others. Nano I haven't used as much, kind of a in between VI and gedit, so you get a little bit of a taste of terminal, but it's a little bit more user friendly for beginners. And if you're somebody who's a really avid Linux user, then there's also this Vim, which has a lot of powerful features in it, maybe a little bit less intuitive, but you can do a lot more with it. So different skills of how you can interact with your files, up to you which ones you want to try out and see what works best for you. So one additional thing, bash files we're going to be getting into a little bit. So bash files essentially run like what you would in the terminal itself. And you can do things like have arguments, right? So when you run the bash file, it actually prompts you to put something in, and then it'll run the command. So in this case, if I was to run this bash script, whatever I input into the terminal, it would then echo out or print out that input. But the other thing that I really want to highlight, and we're going to run into this if you use something other than the virtual machine, is that to actually run ROS, you have to source a bash file. So sourcing essentially means that you run that bash file, and the bash file basically is going to tell the system where the ROS stuff is that you're looking for. And so it turns out that the bash RC file automatically runs every time you open a terminal. And in the virtual machine, it has been modified such that it does that initialization for you. Right? So if you go to a different machine, every time you open a terminal that you want to use ROS, you actually have to do that initialization. Right? So if you're ever working with another machine that has ROS and you're not sure why the ROS commands aren't working, that is the reason why. Okay? But if you're somebody who gets more into Linux systems, you can actually modify that bash RC file to do a lot of different things on startup for you. All right, so I know that was kind of a lot of Linux stuff. So just kind of giving you a broad overview. I know it can probably be a little bit intimidating as you're hearing there's so many different things that you can do. Hopefully, as you're going through the first web, it'll give you a little bit more guidance on some of the ones that you're going to use the most. As I said, there is a common commands on the Piazza site that you can take a look at. Linux quick reference. Right, so this can be a useful thing to have with you, right? So it kind of has all of the different commands and what it is that they do. So if you're trying to figure out how to do something in the terminal, right, it has all those tons and tons of different ones that you can use. Most of them you probably won't for this class, but they're available to you as a quick reference. So any questions about any of that? Now it's kind of a lot, kind of giving you an overview, and then hopefully in the lab you can actually play around with it, get a little bit more of a feel for how Linux systems actually work. So the last thing I kind of want to do is just a little bit of a ROS intro. So a lot of this actually talked to a few students about before class started, but ROS itself, so it is robot operating system. It's not actually an operating system. It's really more kind of this in between that has some software functions. It does data exchanges. So some of the functions of an operating system are there, but it's not actually an operating system. Okay? I'm not a CS person, so that's probably about the most technical description that you're going to get from me. So if you are a CS person, I apologize. If you're not a CS person, it's good enough to know it's a thing that operates between other things. Right? So the idea is that what we're going to see is that you can build what we call nodes, and these nodes are going to basically be chunks of code that do things, and then we can connect these nodes together. We can actually monitor what's going on between these nodes and see how they're communicating, see what information they're exchanging. And what we can actually do is cooperate a whole bunch of nodes doing different things, rather than having this one massive large program that we're trying to run. And also by separating this out, it allows us to have different pieces of code. We have different languages running, all communicating to each other by utilizing this ROS framework in between. And so a couple of the key ideas, like nodes are essentially those single programs that do something. And the most common that you're probably going to encounter are C++ and Python. Those were the originally supported ones. But you'll see that there's also support for MATLAB, for Java. I think they're working on Rust as well. And so there are lots of different languages that have a client library. So the client library essentially does whatever modification to the data forms to be able to do information exchange, right? So since most of us are not CS people, we don't need to worry about what exactly that is doing, but we just know that, hey, there's a thing that allows us to do this. Okay? And then the nodes can communicate to each other through different ways. So the way that we primarily do that is through something like topics. So you can almost kind of think of it as, say you have a bunch of mailboxes, each mailbox is a node, and then the topic is kind of like a pipe between them, and then the message is the form that you actually use to exchange information between those boxes. So as we start looking at ROS specifically, we'll see some of the constraints that we have for defining these things. And then another term that I've used a couple times is package. So package is basically just, we take a whole bunch of nodes that work together to do a certain thing, lump them all together into what we call a package, right? So I have an example of how something like this might work, right? So maybe you have a camera, and what you want to do is you want to be able to take images from the camera, add lines to it, and display it to some monitor. So instead of just having one big file that does all of this, we might break it up into one node where its only job is to read the image. We have another node that all it does is when it receives an image, it puts lines on the image everywhere it detects a line. And then, so maybe that first one detects them, and then we have another node that actually merges together the line information and the image itself. And then we actually have a node that does the display, right? So in this way, we've been able to break apart each of these functions. What's nice about this is that we'll see what we can actually do is simulate. So I can generate some fake images and see what this node does, right? Monitor this, say, line image output. So I can debug this on its own. I can debug the read image node on its own, right? So I can do each of that debugging separately instead of having one giant file that does 4 different things, and then I have to figure out what's wrong with it, right? So that's one good thing. And it could also be that maybe I have multiple cameras and I want to do this line detection for each of them. So I can actually reuse that node for each camera, right? So rather than having, here's one program running for this camera, here's one program running for that camera, I can actually reuse that code and essentially have multiple instances of this running, right? So we'll say a very powerful tool, allows us to do a lot of different things with it that really wouldn't be possible without a structure in place like this. And so kind of the last thing that we'll get into a little bit when we actually start working with ROS is that kind of the general structure, what you're going to have is what we call a workspace. So the workspace is where you're going to collect together all of your packages that are essentially for the same project you could think of it as. And then within that workspace, you're going to have the individual packages, which maybe do some specific thing, right? So maybe you have your workspace is for your robot work cell. Maybe you have a package that is for your mobile robot. You have a package that does everything for your arm robot. You have a package that does all of your camera stuff, right? So you have all of them work together. That within the packages, you might have a bunch of nodes that work together to do whatever you need to for that package, right? So you're going to end up seeing that there's very specific file structures that pop up because of the way that ROS works. And so kind of as a consequence of this, what you're going to find is that being careful about where you're doing things is going to be very important, right? So one thing when you're used to using Windows systems, right, you just generate a file. Oh, actually, I don't want it here. I'm going to copy it, put it over here, put it over there, right? With something like this ROS framework, if you have something in the wrong location, and then what we'll talk about a little bit later, what you have to do is build your workspace. So essentially, there's a bunch of stuff running in the background that's going to tell your system where everything is located. And so if you have a file in the wrong spot when you do that, it's going to mess things up, right? So we're going to spend some time talking about what that structure is, make sure that we have good practices of where everything is located, essentially get a workflow to make sure that we don't run into problems later on when we're doing things like the building process. Right? So again, maybe a little bit of a high level data dump is one of those where kind of a chicken and egg problem where, you know, do I talk about what nodes are and then build it up to a workspace? Do I talk about a workspace, break it down to nodes? So I kind of do a little bit of a back and forth of giving you the high level and digging down. If at any point you find that as we're going through digging into this a little bit more, that just the format of presentation is just not really making sense, then definitely let me know. We can make some adjustments to that and hopefully clarify what's going on. It is one of those that once you actually start working with it, it makes a lot more sense than when I'm just talking about it. So that's why we're going to try and do a lot of in-class work time, because that's where you're really going to get a feel for things like, you know, it's easy for me to say, oh, well, there's this structure. But once you're actually in the Linux system and you start moving around, you say, oh, now I see what that structure is, right? So that's kind of the hope for this class, is that as we progress through, you know, there's going to be some lectures where I'll start with kind of going over some of the concepts like this, and then the rest of the class will be working on the lab components themselves, so that myself and the TA can float around and hopefully help you if you run into problems. Since you have your working groups, that also gives you a point of contact where hopefully multiple people have encountered the same thing, or just a second set of eyes that can say, oh, well, you just missed a comma here, right? So hopefully this won't be too daunting of a course if you're coming from a background that's not really heavy in kind of CS type stuff. I'm definitely not expecting you to be really well versed in CS, so I'm going to try and give you templates, try and give you good level of hopefully a good balance between here's step by step what you need to do versus a little bit of exploration. And so you'll actually see that a little bit in later labs as well. So I have them broken down into, right, so if we take, for example, lab 2, right, so you'll notice as you look through, I tried to color code. So action is something that you actually do. Question is, here's something you might want to think about, might be good to include in your report. And then notes are just, here's a little bit more information about this thing that you just did or are about to do. And then there are some cases where I might have something like this, right? So a little bit of a challenge where I kind of walked you through how to do it for this specific example. Now I'm going to change what we're trying to do a little bit. Can you do that? Right? So kind of helps guide you through what you can expect each line as you're reading it, what's going on in there. So actions should hopefully be relatively straightforward. Might require you to think a little bit, maybe go back to something you previously did in the lab. Challenge is kind of bring everything together and see if you can apply it to something different. Right, so as you're going through, if at any point anything in this doesn't make sense, anything is unclear, then definitely let me know sooner rather than later, right? So I can kind of adapt this, make sure everyone's on the same page, and that hopefully it's clear, easy to follow, but still it gives you a chance to kind of explore and challenge yourself a little bit. Okay. So I'm going to end there. And if you run into any problems as you're going through the install, I definitely like everyone to have the VM set up for Tuesday. So then we can do set up with GitHub, make sure you have those connected so that for lab 2, you can start putting your files on there as well.